All right, today we're going to dig into one of the most famous stories in all of mathematics. It's about a theorem you absolutely know, but it features a name you've probably never heard. And honestly, it might just change how you think about the history of discovery. You know this one. I mean, come on. A squared plus b squared equals c squared. It's burned into our brains from geometry class. It's simple, it's elegant, but who do we have to thank for it? And yeah, if you ask pretty much anyone, they'll give you the same name. Pythagoras, the ancient Greek genius. His name is so connected to this theorem, we just call it the Pythagorean theorem. It feels like a fact set in stone. But what if I told you that the story we all learned isn't, well, it's not the whole story. Not even close. What if the earliest person to clearly write this principle down lived centuries earlier, in ancient India? Just look at this timeline. It really puts things into perspective, doesn't it? Over here, we've got Baudhayana, an Indian mathematician laying out the theorem around 800 BCE. And then way over here, more than 200 years later, Pythagoras is born. That's not a small gap, folks. That's a huge head start. So, who was this guy, Baudhayana? Well, to understand his discovery, we have to understand his world. And in his world, math wasn't just for textbooks. It was sacred. Baudhayana's work shows up in these amazing texts called the Sulba Sutras. Now, these were not abstract math papers. They were practical guidebooks for priests. The word sulba literally means cord or rope, which is exactly what they used to measure and build these incredibly precise fire altars for their rituals. This was math born from a very real, very sacred purpose.
Okay, so what did Baudhayana actually write? Let's get right to the source and look at the evidence from his text, which dates all the way back to around 800 BCE.
Here it is. This is the direct translation. The diagonal of a rectangle produces both the areas which the two sides produce separately. Now, that might sound a little clunky to our modern ears, but let's just break it down. The area produced by a side is just a geometric way of saying that side squared. So he's saying the square of the diagonal, our C, is equal to the sum of the squares of the other two sides, our A and B. It's the exact same theorem, just described with words and shapes instead of letters. And this wasn't just some abstract idea he had. He listed specific, practical, whole number solutions. You know, like 3, 4, 5, or 5, 12, 13. We usually call these Pythagorean triples, but when you see this, you kind of have to wonder, maybe we should be calling them Baudhayana triples. This shows he knew exactly how to use this principle to build perfect right angles. Now, to be fair, ideas about this relationship were definitely in the air in the ancient world. It wasn't just happening in India. So let's zoom out a bit and see how this fits into the bigger global picture of ancient math. 1,000 years before Baudhayana, a Babylonian clay tablet listed a whole bunch of these number triples. So the Babylonians clearly knew the calculations. They knew the numbers worked. But here's the crucial difference. Baudhayana was the first person we know of to state it as a general, universal theorem and provided geometric justification. He moved it from just a list of useful calculations to a full-blown concept. So this is really the key point here. The conversation isn't about who owned a theorem, because knowledge gets shared and rediscovered. It's about recognizing who first took that massive leap from knowing a few examples to articulating a universal principle that works for all right-angled triangles. And the earliest evidence we have for that, it points directly to Baudhayana. And believe it or not, this isn't just some dusty old academic debate. This new understanding is actually changing how math is taught right now, today. Let's see how this is playing out. This is pretty amazing. In India, the national organization that sets the school curriculum has officially updated its 8th grade math textbook. It now explicitly credits Baudhayana and the Sulba Sutras for giving us the earliest known version of the theorem. This is history being corrected in real time. And this isn't some fringe theory. This change is backed up by decades of serious scholarship. The historian of mathematics, George Geevarghese Joseph, puts it very plainly, saying the Sulba Sutras contain the earliest known statement of the theorem. This is a view shared by many experts who've looked beyond the traditional Eurocentric story. So after all that, what's the big takeaway? How should we think about this new, more complete story of one of the most important ideas in mathematics? Let's just sum it up. Baudhayana's contribution is absolutely foundational. Why? Because he articulated the theorem centuries before Pythagoras. He gave us a clear concept, not just a laundry list of examples. He backed it up with geometric reasoning. and his work was part of a long, thriving mathematical tradition in India. And I want to be really clear here. The point is not to erase Pythagoras or diminish the incredible work of the ancient Greeks. That would be absurd. It is simply about historical accuracy. It's about restoring a little balance and putting Baudhayana where the evidence shows he belongs. Not necessarily above Pythagoras, but definitely before him.
And that really makes you think, doesn't it? If a story this fundamental, one we all thought we knew, was incomplete for so long, what other official stories are out there in science or art or history just waiting for us to rediscover them and finally understand the full picture? Thanks for joining me on this one.